Hi there. Today we're going to be looking at Unit 8B.4e. And what we're going to do is do something called, we're going to use the Pythagorean identity. Okay, so first of all, what is the Pythagorean identity? When we talk about the Pythagorean identity, we are talking about the following. This is what it looks like. Sine square theta plus cosine square theta equals 1. Now, I feel like we haven't seen this notation, and I want to make sure you understand what this means. This doesn't mean that we're squaring sine. This is just another notation. So I'll just make that little note here that when we see sine square theta, this really means the sine of theta, that quantity squared, okay? When we write it like this, however, we don't need those parentheses. If we didn't have the parentheses there, if we just wrote sine theta squared, people might think that we're squaring the theta when we're really squaring the value of the sine function. And then you need parentheses. Well, the nice thing about putting the squared part here is that you don't have to worry about that, okay? So that's the same thing for cosine square theta. And I'll just make a note that cosine square theta, what that really means is that we're taking the ratio cosine of theta and then squaring it. All right, so this identity is true for all real values of theta, and it's a result of applying the Pythagorean theorem on the right triangle that is formed in the unit circle for each theta. We know that in the unit circle, we can have these different triangles, all right? And we see, and it's hard to see this, that the x, as we move along the x on the unit circle when we have our ordered pairs x, y here, the x part is cosine theta, and the y part is sine theta, and then in the unit circle, the r value is 1. So when we think about using what we know about that right triangle, that x squared plus y squared equals r squared, when we're thinking about the unit circle, we know that on the unit circle, x is the same as cosine. We know that y is the same as sine, and r is 1. And I don't know why traditionally they start with sine squared theta plus cosine squared theta equals 1. You can see that these are similar because of the commutative property that of addition, that sine squared theta plus cosine squared theta equals 1. Okay, but this is the identity that we're going to be utilizing today. So what problems can I solve with the Pythagorean identity? Like any identity, and you're going to learn a ton of identities in pre-calc or algebra 3 next year, the Pythagorean identity can be used for rewriting expressions in equivalent, more useful forms. You're going to do that a lot in pre-calc in algebra 3, okay? So this will be really nice that you kind of have an idea of what this Pythagorean identity is. And there are two other ones. We just focus on this one here in algebra 2 with trig. So another thing that the Pythagorean identity does is it allows us to convert between sine and cosine values of an angle without knowing the angle itself, like if it's not on the unit circle, or if it's not like one of the special angles on the unit circle. So let's consider the angle theta that's in quadrant 4, and sine of theta is negative 24 over 25. Now that can still be on the unit circle. It's just the ratio is just negative 24 over 25. So what we can do is use the Pythagorean identity and the value of sine theta to solve for the cosine theta. So all these are already, these steps are already done for you. So notice that we have this step here. We have our setup step where we use the Pythagorean identity. We then have the next step where we're going to substitute the values in. So again, we know the value for sine, so we substituted that in. Next, what we want to try to do is to isolate our cosine, to isolate whatever trig function that we have, and then take the square root. And then what happens when we take the square root is we end up with two possibilities. We have a positive or a negative when we take the square root. And what we do is the sign is determined, so I'm going to just circle this, the sign is determined by the quadrant. Sometimes we're going to be finding cosine today, sometimes we'll be finding sine, but it's always determined by the quadrant. This problem said that it was in quadrant 4, and we know that in quadrant 4 the cosine is positive, so here we are going to say that the cosine of theta is a positive 7/25. So from here to here, what we really are doing is we're going to think about the quadrant. And that'll help us determine the sign. Okay, so we have a worked out example there. Let's try a couple examples on our own, okay? So example 2, which we have to do work for, says if the angle theta is in quadrant 3 and cosine theta is -3/5, what is the sine of theta? Well, we know that in these questions, we're going to be using sine squared theta plus cosine squared theta equals 1. We'll be using this Pythagorean identity. And here they're just telling us that the cosine of theta is going to be -3/5. So I don't know sine of theta, but I do know that the cosine of theta is -3/5. Now, remember that cosine square theta means that we're taking the ratio of cosine theta and we're squaring it. So that's how we should write it in our substitution, as -3/5 squared. And then that equals 1. I would then evaluate what this is here to try to do the solving work. Remember, you have to square the -3 to make 9. And we square the 5 to make 25, and then that equals 1. So then we could subtract 9/25 from 1. And to do that, we probably need a common denominator. So we need this 1 to really be something over 25. Well, obviously, 1 is the same as 25/25. So if I were to subtract 9/5 from 25/25, I end up with 16/25. So if I take the square root of each side and think about that plus or minus, remember when you take the square root of a fraction, you take the square root of the numerator, which is 4, the square root of the denominator, which is 5, and we said that that was plus or minus. Okay, so we have to decide which is it, because it can't be both at the same time. We know that this is in quadrant 3. And let's think about what was positive in quadrant 3. Remember how we talked about all students take calculus? All trig functions are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3, and cosine and secant are positive in quadrant 4. So that means in quadrant 3, that sine is not a tangent function. So we know that in quadrant 3, that the sine is negative. So what that means is that we're going to choose the negative value, and our answer will be -4/5. And that's what we'll be doing, okay? Let's do another one. Example 3, it says if the angle theta is in quadrant 4 and sine of theta is -1/2, what is the cosine of theta? Well, once again, I can use this idea that sine squared theta plus cosine squared theta equals 1. And in for sine of theta, I would put -1/2. I don't know cosine, and I can go from there. Now be careful squaring. Remember, a -1 squared is 1. Let's do that in this color. And then we have to square the denominator, which is 4. and then we have plus cosine squared theta equals 1. Now I want to subtract 1/4 to get the cosine theta by itself. And we can probably subtract 1 minus 1/4 pretty easily, but remember, if you're thinking about kind of like what to do if it's not familiar, we want to make a common denominator. So 1 is the same as 4/4, and 4/4 minus 1/4 is 3/4. So then we'll take the square root and then do a little plus or minus there. So we know that cosine of theta is going to be plus or minus. We'll take the square root of 3. We don't know what that is. And there are no perfect squares that go into 3, so we'll leave it as root 3. And now we take the square root of 4, which is 2. So now we're going to think about the quadrant. And notice that we're here in quadrant 4 for this question. So in quadrant 4, cosine has what sign? It is positive. So what we'll choose is that cosine theta is going to be positive root 3 over 2. And again, I don't need to see the plus sign. I'm just being dramatic, but it does show that we've thought about it and what the sign should be. Okay. Is that pretty good? Why don't you guys try example 4 and see if you can, the numbers get kind of big here, but see if you can figure out how to set this up and find the cosine of theta for this question. Okay. Okay. All right. So how do we do on this one? Let's double check our work. Here's what I had. I put 9/41 in for the sine of theta, and I was able to find a common denominator of 1681. And even though that was kind of a big number, I tried to take the square root and it worked. I took the square root of 1600 to be 40, and the square root of 1681 ends up being 41, so that was nice. And then since I'm dealing with quadrant 2, cosine is negative, so my answer is negative 40 over 41. Let's just do one more. Just want to make sure you know they're not always going to be super pretty. Here we have that the angle theta is in quadrant 1 and that cosine theta is 13 over 30. So again, we're able to use this Pythagorean identity because there's that relationship, like they give us cosine or they give us sine and they want the other one. Okay, so that's a nice thing for us to be able to use this for, just going between sine and cosine. So I don't know what sine is, but I know that cosine of theta is 13 over 30. And then I can square 13 to make 169, square 30 to make 900, and then set that equal to 1. So now I want to subtract 169 over 900 from 1. So I'm going to think about 900 over 900 as 1, and then subtract 169 from that. So I get 731 over 900. Once again, I'll want to take the square root. And again, we do want to think about it being plus or minus. So now I know that the sine of theta could be plus or minus. And now I have this square root of 731. Let's see if 731 is a perfect square. It's not. We should see if there are any perfect squares that go into 731, but when we start looking at the perfect squares like 4, 9, if 4 doesn't go in, 16 won't. Obviously 29 isn't going to go in, or sorry, 25 isn't going to go into that. If 4 and 9 don't work, 36 doesn't work, 49 doesn't work. It turns out that 731 can't really be simplified. There aren't any perfect squares that go into that. So that means that we can just leave that as root 731. And what about the square root of 900? If you try that, that does give us 30. So that's